Now that we have the quotient and the product rule at our disposal, we can do the rules for the other trig functions. Let me just focus the camera. Okay, that's worse than it was before. Let's try that again. Perfect. Okay, other trig functions. The derivative of tangent is secant squared x. The derivative of secant will be secant x tangent x. The derivative of cotangent gives you negative cosecant x all squared. And the derivative of cosecant is negative cosecant x cotangent x. Now for these proofs, we don't have to use the limit definition, although you actually are able to. But it's easier to use the rules that we've already proved to then prove these. For example, tangent we know is the ratio of sine over cosine, which means we can use the quotient rule and the rules for sine and cosine with it. Actually, let's do that one out really fast, just to kind of show how that turns into secant squared. So we know the derivative of tangent is the derivative of sine over cosine by definition of tangent, right? It's like the ratio identity. Sine over cosine is a quotient, so it's the derivative of the top times the bottom minus the top times the derivative of the bottom, negative sine, which I have to write so small because I'm not doing a good job with space management, over the bottom function squared. The top turns into cosine squared minus negative sine squared, or cosine squared plus sine squared. And cosine squared plus sine squared is 1 by the Pythagorean identity. And 1 over cosine squared is secant squared by the reciprocal identity. So tangent differentiates to secant squared. The proof of cotangent's derivative is pretty much the exact same. Secant I want to prove, because it also has kind of a weird step to it. So we want to find the derivative of secant. So the way to do that is to treat it as the derivative of 1 over cosine, which is also a quotient. But when you differentiate that, the derivative of the numerator is 0, because 1 is a constant and its derivative is 1 times the bottom function, minus the top function times the derivative of the bottom function over the bottom function squared. Simplify this, we get just sine over cosine squared, which is correct, but we can use the identities to rewrite this as sine over cosine times 1 over cosine, which is where the answer came from. Tangent x times secant x. And the proof for the derivative of cosecant is pretty much the same thing. So kind of the lesson here is if you ever do forget the derivative of cosecant, which is possible because we don't use it too often, or if you forget the derivative of cotangent or tangent, you can just use the rules for sine and cosine to derive those rules.